Okay, let's do tutorial number 8. So we're going to go down memory lane and we're going to remind ourselves about the different types of numbers that we've been working with and we will continue to work with. The first one is real numbers. So what I like to say about real numbers as I'm stepping on my mic, what I like to say about real numbers is they're any number whose home is on the number lines. When you think about a number line and think about all the different numbers that are located there, of course, 0 and 1 and 2. In fact, why don't we stop here because right now what I'm writing, do you know what these numbers are called? These are called integers. So let's scooch down. We'll get back to real numbers in just a second. So integers are all the positive and negative whole numbers plus 0, right? Because 0 is neither positive nor negative. So the integers would be like -10, -9, -8, -7, etc., all the way up till 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on and on. So those are the integers, and the integers are located on the real number line. And so let's keep going, and we'll add to the real number line. How about that? Let's see, rational numbers. So rational numbers are any number, and why am I doing it all in the same color? How boring. Let's switch up colors. So rational numbers are any number that can be expressed as a fraction. So that includes obvious ones like 1/2, right? Or how about this one would be -3/2, right? -1/2 would be -3/2. But also, really, all the integers, right? 2 could be expressed as 2/1, I mean, technically. All right, so that's rational numbers. So what do you think if rational numbers can be any number that can be expressed as a fraction? What do you think irrational numbers would be? Yeah, it makes sense that irrational numbers are numbers that cannot be expressed as a fraction. So when you think about that, okay, so far all the numbers we've been talking about, like, -4, well, that's -4/1, haha, that's a fraction, and 100/100/1, that's a fraction, and of course, fractions we're used to 1/2 and 1/4, and even the improper fractions like 7/3. Those are all on the real number line. So let's think of a number that can't be expressed as a fraction. And so if you think real quickly, even on your calculator, you're going to see that we've got a number, an irrational number, and it's pi. If you hit pi and then hit your double arrow or hit enter, it's going to give you what, 3.14? Oh, I wish I was one of those geeks that knew all the numbers, but I don't. Okay, after 0.14. But it goes on and on and on, and it's not a repeating decimal like 1/3 is 0.33333 repeating. Those repeating ones can be changed into a fraction, but the ones that go on and on and on forever, like pi, cannot be changed to a fraction. Another one that can't be changed to a fraction is e. And I'm going to probably mispronounce this. It's probably Euler's, but I like to say Euler's. It just sounds better. But okay, somebody can correct me out there. But e is 2.7 something, 2.71 something. That also goes on and on and on. If you hit your e button on the calculator, you'll see that that can't be changed into a fraction. So fascinating, right? There are numbers out there that we cannot write as a fraction, and those numbers are called irrational numbers. Another number, like what if you put square root of 2 in your calculator and then hit enter? You're going to see a decimal that goes on and on and on with no repetition. But all of those are located, believe it or not, on the real number line. Like pi is 3.14. Pi is going to be somewhere around there. There's actually a place for it because pi is located between 3.1 and 3.2 on the number line. And e, that being 2.7, that's going to be located right around here. And square root of 2, if we hit square root of 2, is that 1.4? I don't know, it's somewhere between 1 and 2. So there's going to be a place on the number line for irrational numbers. All right, let's keep going. You're like, Ms. Overby, why are we doing this? We haven't talked about this since elementary school. Yeah, that's why we're doing it. It's really important because we're going to be talking about rational and radical numbers, and I thought, why not review everything? Radical numbers, those are like the cool numbers, right? The radical. Radical numbers, normally we think of this sign as a square root, and we can call it a square root, but when we see something like square root of 25, that's also called a radical number. It's expressed in a radical form because the square root is called a radical. That's a radical sign. All right, so square root of 25 we know would be 5, right? And then we've seen square root of 2. Square root of 2 is both a radical number and an irrational number. So radical numbers are on the number line. Let's go ahead, that's 4, and then let's do square root of 25. So we see that radical numbers are also on the number line, so they are also real. All right, and then we've got imaginary numbers. Let's see, do we have anything else after imaginary? So imaginary numbers, you know how like the square root of 25 is equal to 5? Well, how about the square root of negative 25? We know square root of 25 is 5 because 5 times 5 gives us 25. But what times itself gives me negative 25? Yeah, it's actually the answer is 5i. I know, don't worry about it. You're going to see it in Algebra 2. But that's an imaginary number, and that doesn't go on the real number line. So what's a real number? A real number includes any number you see on the number line, on the real number line, including integers, rational numbers, irrational numbers, and radical numbers. All right, how is that for a good review? All right, so why are we doing this? Well, look at this. Look at the directions here. I didn't want you to be confused. Radical, rational, what in the heck? Well, now we know a radical number is anything with a square root sign, because that's a radical sign. And rational is any number that can be expressed as a fraction. So you're like, okay, well, wait a minute. This is new. Square root of x, how many? Okay, well, I'm going to give the first one to you. So here's the deal. Remember how when we have a power like x cubed we know is x times x times x. But how are we going to express square root of x as x raised to something? Well, here's the deal. A power, an exponent, can actually be expressed as a fraction. So in this case, it's going to be 1/2. Now that's different than x squared, right? X squared is x times x. Well, when we see x to the 1/2 and we see the 2 is in the denominator, that tells us that's the same thing as square root of x. In fact, the index, I believe this number right here is called the index. We really can write this as square root of x with the 2 tucked in there. All right, so I know it's new, but just trust me, it's going to make sense in just a little bit as we just hit it over and over again. So here we go. If I wanted to write the same thing and you're like, oh, Miss Everblue, what's that 3 doing there? All right, so let's go backwards. When you don't see a number, we say square root of x. When you see a 3, that index number is a 3 tucked into the square root sign, we say that's the cube root of x. Okay, if you saw x cubed, right, x to the third power is x cubed, we know that's x times x times x. But in this case, this is saying the cube root of x. And we could also write that as x to the 1/3. So this lesson is just introducing you to the fact that, shocker, your power can have a fraction. And the denominator of that fraction is totally different than when there's just a power in the numerator or just by itself. Like, I mean, we could write this as a fraction, right? 3/1. So your numerator is going to be your power and the denominator is going to be your root. All right, so what do you think? We could say, this is how we pronounce this when we see a 4 as the index number, that's the 4th root of x. And how do you think we're going to write it? That's right, x to the 1/4. Here, we'll call this the 5th root of x, and we're going to write it as x to the 1/5. You know, I realize as I'm teaching it, you're like, why would we ever want to do these things? Well, sometimes it's interesting. Like, you know how it's interesting to say, hey, what's the square root of 25? All right, well, first of all, we just learned we could rewrite that as 25 to the 1/2, all right? But no matter how you write it, we know that the square root of 25 is 5. Either we can pick up our calculator and do that, or we just know 5 times 5 is 25, so the square root of 25 is 5. But wonder if somebody asked, hey, what's the cube root of 8? And yes, now we learned from today's lesson, you can rewrite this. All right, that's not really the important part, but you do need to know it. But it's kind of fun to think of, wait a minute, if the square root of 25 meant what two numbers, what number out there would multiply by itself gives me 25, the cube root of 8 is saying what number out there when you multiply it by itself 3 times gives you 8. And yeah, it's going to be 2, right? 2 times 2 is 4, times 2 is 8. So the cubed root of 8 is 2. So I know that I'm kind of jumping all over the place in this lesson. Don't leave this screen until you figured out, or this slide, or this part of the notes, until you get, yeah, I get it, Miss Overby, when we're dealing with radicals. And this is a radical sign. We call it a square root sign, but it's really also called a radical sign. That when we don't see a number in, this is our index right here, we don't see a number right there, we know that's really a square root, and we could write it with a 2 in there, but nobody does. That's the same thing as writing x to the 1/2. These two are the same thing. They're telling the same thing. We see the cube root, and we say cube because the 3 in there. We can also write it like this. That's really what, 2 different ways to write it. It's important because when we get to calculus and we do derivatives, it's really important to be able to write your radical as a rational exponent. So we're getting ready for calculus, right? All right, so let's see. Convert the rational expression to an expression in radical form. So now we're going to go back. So we're really just, once again, practicing how to go from one form to the next. All right, when we see x to the 1/2, totally different than x squared, right? X to the 1/2 is the same thing as square root of x. What do you think x to the 1/3 is the same thing as? That's right, we're just going backwards. We know this, the cube root of x. And then x to the 1/4, if we're going to switch it to radical form, is the 4th root of x. All right, good to know. All right, so now we're actually going to have some fun here. You can use your calculator, all right, but I'm going to challenge you to not reach for your calculator yet. There's a couple ways that you could use your calculator. You could see that we do have, when you hit the second button, you can hit the little thing that's got a place for you to put the 4, or the 3, or the 5. Or you could switch that to, you could do 81 to the 1/4 power. So you could do the up button. A couple different ways. I'll show you in class. But also I think it's fun to just do these in your head. All right, so this is saying that there's a number out there that when you multiply it by itself 4 times, it's going to be 81. Well, you just mess around with numbers, and 2 times 2 is 4, times 2 is 8, times 2 is 16. No, it's not 2. Let's try 3. 3 times 3 is 9, times 3 is 27, times 3 is, it's 3, that's 81. All right, so you have 2 options. You can either do them in your head, have fun, or just pick up the calculator. All right, the cube root of 64, we're thinking of 3 numbers that when you multiply, we're thinking of one number that when you multiply that number by itself 3 times, you get 64. And I don't know about you, but it just shouts 4 to me, right? Because 4 times 4 is 16, times another 4 is 64. And if you go this route of trying to mess around and finding your own answer without picking up the calculator, you'll get a greater sense. You'll get a greater number sense. And that's always important in math. All right, so now we're looking at finding a number that when you multiply by itself 5 times, 1, 2, 3, 4, 5, it gives me 32. What do you think? Yeah, pause me. I am going fast to make the video a little shorter so it looks more watchable, not too daunting. All right, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the 5th root of 32 is 2. And let's do this last one. We've got, think of a number that when you multiply it by itself 3 times, what is it? That's right, it's 5, right? 5 times 5 is 25. 25 times 5 is 125. Once again, see if you can figure out how to do it on the calculator as a backup. And if not, please ask me in class. Let's see if we've got anything else. That's it. All right, that was short but sweet, and a new introduction to some different ways to write numbers. Thanks for joining me. I will see you in class.